what is a magnetic field? We define a magnetic field based on the force that it would exert on a particle. The field itself occupies a region in space such that every point in that space defines both a magnitude, the strength of the field, and the direction of the field at that point. Magnetic field strength is measured in units of teslas. Unlike electric fields, which can originate from fundamental charges in nature, like electrons, magnetic fields do not have a magnetic particle of origin. However, certain charged particles do manifest a magnetic field. For example, electrons have a spin, which is a quantum mechanical property, not a literal rotation, which is inherent to the particle, just like mass or charge. The electron spin generates a magnetic field. Additionally, electrons also have orbitals in atoms, which also produce magnetic fields in a material. Some materials, like ferromagnetic elements such as iron or nickel, have electron regions where the magnetic fields are aligned to produce stronger fields. It is possible to apply a strong external magnetic field to the material to align these regions together. When the external magnetic field is removed, the material continues to possess a permanent magnetic field. Magnetic fields are also generated by moving charges. If a charged particle possessing charge amount q moves with a velocity v through a magnetic field B, the particle will feel a force. The magnetic force is directed perpendicularly or to the side of both the travel direction of the particle and the direction of the magnetic field. This means that the magnetic force on a charged particle does not have a component pointing along the forward path of the particle's motion, so it can't change the speed of the particle or its kinetic energy. It can only change the particle's direction of motion. We can visualize a magnetic field by looking at a bar magnet. We draw field lines as a visual aid to help see the magnetic field through space. Note that a real magnetic field permeates the entire region of space and is not made up of actual lines, but this visual helps to understand the field better. The magnetic field lines pass through the body of the magnet in closed loops. The fields originate from the North Pole and loop back through the South Pole. Notice that the field lines are bunched up closer together at the poles, which depicts that the field is stronger there. Opposite poles attract and like poles repel.